So I've got this NAD 3120 here from about 1985. This is a variant of the 3020, more precisely a variant of the 3020B, minus tone controls and minus power meter. Apart from that, it's essentially a 3020B. So this unit has a little problem, and I'm going to show you right now what that is. So this is a variant of the startup hum problem. There's a few videos out there on YouTube already that show this problem. This is not quite the same. Usually it's much worse, but it's still a variant. And it's caused usually by some capacitors, precisely those three capacitors there, one of those. But I've replaced these. Those are brand new capacitors. I've replaced all the electrolytics in this unit. So it's not that. So we're going to dig into this and see if we can resolve this problem. So I'll just take you through the schematic so we can see what this muting circuit is supposed to do. So here are the outputs of the preamp stage. And I know that this noise is coming from the preamp stage because if I pull out the links that connect this through to the power amp stage, the noise goes away. Now I also already know that the noise is coming from this muting circuit because we have these JFETs here, and if I short out these JFETs, then the noise is gone. So what this muting circuit is supposed to do is disconnect these JFETs when the unit's first turned on and also when it's turned off. And here's basically how it's supposed to work. So down here we have a power transformer, and we have this tap coming off secondary of the transformer to this point here. You'll see that this is one side of the input to the bridge rectifier. So that tap is taken and it comes up to this circuitry here. So basically as soon as mains is applied, there will be secondary AC voltage will appear here. This circuit is a voltage doubler. So what it does is generate about minus 60 volts. So immediately when the amplifier is turned on, this voltage doubler will start up. There will be minus 60 volts will appear here. This switch is closed when the unit is off. It's open when the unit is on. So this circuit will charge up through this capacitor and it will reverse bias this diode, D507. A diode, when it's reverse biased, acts like a capacitor, so there's no DC path, but that's fine because what we're trying to do is to reverse the gates, reverse bias the gates on these JFETs so that they're switched off. So this diode is reverse biased. You'll notice on the data sheet that the negative voltage on these gates, I think it's rated to about minus 30 volts. And you'll say, well, there's minus 60 volts here. Yes, but we're not connecting it directly. It's going through this diode, which will be reverse biased when this is negative 60 volts, so we're not directly connecting that to it. All we're trying to do is dump enough negative charge into the gates of these JFETs so as to bias them off. When we turn the unit off, this switch will go to the closed position as shown, and that switches back the minus 60 volts again to reverse bias these. Normal operation, we have this voltage here. Now there's an error in the schematics. I've crossed it out so I can't see what it actually said. I think it said something like plus 29.5 or something. There is no plus 29.5. I scoured the circuit trying to find where this came from. It doesn't come from anywhere. So I then got the multimeter out and buzzed out where it comes from. This is plus 33. So that's this plus 33 here. This is the output of the power supply that powers most of the amplifier. So basically what's supposed to happen is when the unit starts up, it takes a while for the voltage rails to stabilize. So it takes a while for this plus 33 volts to come up. When this voltage comes up, this diode will be forward biased and the JFETs will be turned on, thus connecting the preamp stage through to the power amp stage. So put simply, what's supposed to happen at turn on, there's supposed to be minus 60 volts generated here, applied through this reversed bias diode to the gates of the JFETs to turn them off. Then slowly this plus 33 volt rail comes up, and as it comes up, the JFETs get turned on. And essentially the reverse happens at power off. Unfortunately, it's not quite working the way that it's supposed to be. So we're going to have a closer look and see if we can work out exactly what's going on and how we can fix that. Okay, so I've got my multimeter connected to the anode of D507, which is our diode that connects this voltage into our JFETs. So I'm going to see at a DC level just what's going on here. So what we can see happened is the voltage went negative. Obviously a bit slow for the meter to pick up things, but the voltage went negative to minus 60 volts. Then the voltage started to come up, and as it went through about minus 10 volts, we heard that noise. And we can see now that it's well and truly forward biased, the JFETs are on, and the amplifier is operating normally. So we're getting that little bit of noise as the bias voltage going onto those JFETs passes through about minus 10 volts. We'll see what happens when we turn it off. See how the voltage dropped immediately to minus 60 volts. There was no noise. So turn off, that's doing what it's supposed to do. If we turn it back on again, there's our noise as it passes through about minus 10 volts. Now you're probably wondering what this funny little arrangement is with the red test clip. What I've done is I've lifted R548. I've lifted the end that's connected to the plus 33 volts. So what this allows me to do with the test clip is to control myself when I apply this positive voltage. So let's just see if we can do this now. A little bit tricky one-handed. Let's put that there so it doesn't short anything. Turn the unit on. There is no noise. And now, if I connect this test point, I hope you saw that, there was no noise. So if I waited a while and then connected the test point, it seems to work. Let's now have a closer look. Okay, so now I've got my shiny new eBay scope is hooked up to, again, the anode of D507, so that we can see what's going on in AC. We already know what's happening at DC, but if we see what's happening at AC, it might give us some clues. So the scope is AC coupled, so it's just a little bit hard to see things because it'll jump around a bit, but it's AC coupled, 10 milliseconds, time base, 1 volts per division. So let's see what's happening. So you can see there's a sawtooth with about a 20 millisecond period. 20 milliseconds is of course 50 hertz, which is the line voltage here in Australia, so that's not too surprising. Now what we can also note, just wait for it to stabilize again. If I turn the unit on again, you'll see that sawtooth starts out quite large, and then it slowly decays to the point of being DC. So we're looking at a time constant thing here. What's happening is that when the JFETs become forward biased enough to start conducting, there's ripple on the gate. That sawtooth waveform that we can see, that's still on the gate. And the voltage isn't negative enough anymore to fully turn the JFETs off. So we're hearing that noise in our speakers when we turn the unit on. So it really looks to me like it's a time constant thing. It might be something to do with biasing, to do with the way that the JFETs are biased as to the point when they start conducting. And also, obviously, it's also to do with when this sawtooth waveform is there. How do we fix this? I really have no idea at this point. But we can either try to change something with biasing of the JFETs, which I think is pretty fraught, to be honest. Because I noticed that even when I put the scope probe on the cathode of that diode, it was enough in cutoff to change the biasing, because remember, effectively the gate is floating when that minus 60 volts is there because the diode is reverse biased. So I suspect that this is actually a big part of the problem. The biasing arrangement, I think, is fundamentally unstable, because at DC the gates of the JFETs are not connected to anything when that diode is reverse biased. They're just trying to dump enough charge in there to reverse bias them, but they're not connected to anything in DC. So it's problematic. So let's see if we have any bright ideas. So I'm afraid I'm going to have to admit defeat on this thing, because I've tried everything that I can think of, and I can make it worse, but I can't make it better. I've tried capacitor values, and that didn't work. I even tried changing the JFETs, just in case some new ones just might have slightly different gate characteristics. That didn't work either. So I can't think of anywhere else to go. But I do know that this muting circuit was not present in the original 3020 design. It was added in later on. This 3020B design, which the 3120 is based on, has it. And then at some point later on, NAD took it out again. The reason being is they couldn't get the muting circuit to work reliably. So what I've done, I've effectively taken it out just by shorting out the JFETs. So it's exactly what the early 3020s and the later 3020s had, in that they didn't have this muting circuit at all. They didn't have those JFETs. Means that you get a bit of a speaker thump on startup, but you don't get that hum sound anymore. So if we start it up, the hum is totally gone, just a bit of a speaker thump on startup. So I'm quite happy to live with that result. I like things to work the way they're meant to work, but my understanding is this circuit never did work the way it was meant to work, which is why NAD took it out again. So I would have liked to have been able to fix it, but we still have a suitable solution. So there we are.